Okay, so in this video, we will learn how to simplify or reduce rational expressions. Okay, and to do that, we must always remember that when we wish to reduce or simplify rational expressions, our goal is to find common factors in the numerator and in the denominator that we can cancel out. So why does it make sense? Because let's say, for example, x, you have a common x in the numerator and denominator. We can simply cancel this one out. Why? Because this is equal to 1. And if the value is 1, then it will not affect anymore the whole expression. Okay? So let's have this example. Okay, let's have this first example. Negative 56 times x raised to 5 times y raised to 3 times z raised to 4 all over 64 times x raised to 6 times y raised to 2 times c raised to 4. Okay, so if we want to factor out this one, or simplify rather, we need to cancel out common factors among this. And let's start with the constants first. So for negative 56 and 64, its common factor is 8, because 56 can be written as 7 times 8, and then 64 can be written as 8 times 8. So we can cancel out one copy of 8, so we will be left with 7 and 8. Now for x, we have 5 copies of x in the numerator. And look at in the denominator, we have 6 copies of x if we will expand this one. To mean that all of this 5 will be cancelled out. And then 5 from this will be cancelled out. So we will be left with only one copy of x here below. Or applying the rule or law in exponents, which is the quotient rule. So simply subtract the exponent 6 minus 5, that is equal to 1. Same thing will happen here. So we have 3 copies of y here, and then 2 copies of y here. So we will be left with 1 copy of y in the numerator, or through the quotient rule, 3 minus 2, that is equal to 1. And for the last one, z raised to 4 over z raised to 4, wherein your numerator and denominator is already or has the same value. So we can just simply cancel this one out. We will be left with just simply 1. Or using the quotient rule, z will be raised to 4 minus 4, that is 0. And still, that is equal to 1. Okay, and with that, we will have now our answer, which is negative 7. So don't forget the negative signs. The negative sign, since 56 is negative. So negative 7 times y over 8 times x. So no need to put power of 1, because that is understood that if you have one variable, then you only have one copy of it. Okay, let's move to the next example. Okay, second example, let's have x squared minus y squared over x raised to 4, y raised to 4. Now the trick in reducing rational expression is you must be able to see already the relationship, so that you can simplify your solution, like this. You can just actually retain x squared y minus y squared, though we can still factor it out. Why? Because if you will notice, this is difference of two squares, and we can expand this as x squared minus y squared times x squared plus y squared, which is equal to our, or common with our numerator, so we can cancel this one out. So we will be left with 1 here. So therefore, our final answer will be 1 over x squared plus y squared. So this is now our final answer. Okay, so for our third example, let's have x plus 3 over 2x squared plus 7x plus 3. So if you will notice here, we can no longer do anything with our numerator, so we must deal only with our denominator. So let's try to factor out 2x squared plus 7x plus 3. So copy x plus 3. For this one, we must think of two binomials here. So let's put 2x here. Let's separate 2x squared as 2x and x. So this is just a trial and error. Let's see if this will work. And then we wish to have product of 3 here. So we can only use 1 and 3, positive 1 and positive 3. Why negative 1 and negative 3? Because our middle term is positive. So let's put positive 3 here and positive 1. And if you will use FOIL method, you will have this answer. You may pause for a while to check if that is correct. And then after that, you can notice already that we have common factor in the numerator and denominator, which is x plus 3. So we can cancel it out, and that will give us 1. So therefore, our final answer will be 1 over 2x plus 1. Okay, that's it for our lesson for today, which is about reducing or simplifying rational expressions. Thank you for watching.